Up to this point in the course, we have been studying derivatives and applications of derivatives. In Chapter 8, we're going to switch our focus to integration. Integration is the inverse or reverse process of differentiation, and it is given many different names. The first title it's sometimes called is the antiderivative, or just integration, or finding the indefinite integral. So those all mean the same thing, just like for a derivative, f prime, dy, dx, slope of the tangent line, instantaneous rate change, all meant the same thing. The antiderivative has many different terminologies for the same thing. So say we're asked to find a function f of x such that its derivative is 2x plus 7. So the notation we use for integration is this integration symbol. It's like an elongated s. And the dx at the end just means that we're integrating this function in terms of variable x. So we want to come up with something that when I take the derivative, I end up with 2x plus 7. Well, let's start looking at these from a deductive, using some deductive reasoning. What term, if you take the derivative, you end up with 2x? Well, I'm hoping you figured out that that term would be x squared, because the derivative of x squared is 2x. Plus, what term do you have that when you take the derivative, you end up with 7? And again, I'm hoping most of you would have figured out that that would be 7x. And then when we're doing an indefinite integral, we also have to put a plus c. Now this c is any constant. And why do I have to put that plus c? Because the derivative of a constant is 0. So it's possible that the constant could be 1, 2, 3, 6, 7. And there are questions that we'll be able to find that constant later on. But right now we'll just put a plus c for being any constant. So this is the definite integral of 2x plus 7. And you can always check if you're correct by taking the derivative of this, which would be 2x plus 7, and I get back what I started with. Okay, let's try a couple more here. So say we're given f prime, which is the same thing as the derivative, and we want to find the function. Well, the first thing I would do is rewrite this. I want the integral of 4x cubed plus 6x minus 10 dx. Again, what is the integral of 4x cubed? So what term, when I take the derivative, I end up getting 4x cubed. Well, hopefully you realize that that is x to the 4th. Plus, again, what function or what term do you get that when you take the derivative, you get 6x? And again, I'm hoping you realize that that would be 3x squared. And my constant, negative 10, well, that term would be negative 10x. And then you have to put plus c. So this would be the definite integral of 4x cubed plus 6x minus 10. Again, you take the derivative of that, and you get what is called the integram, this part right here. All right, next question. I want to take the integral of 9x squared minus 4x plus 2 with respect to variable x. So again, the integral of 9x squared would be 3x cubed. The integral of 4x would be 2x squared. The integral of 2 would be 2x, and I have my constant. So again, this would be the antiderivative of 9x squared minus 4x plus 2. Okay, let's take a look at some basic integration rules. Okay, and the ones that we've been using mostly have been these two right here, but there are more than these. Okay, first of all, the integral of c, where c is a constant, is just some constant x plus our constant c. So again, the integral of 4 dx would simply be 4x plus a constant. So that's what that is indicating. My next one is like the inverse operation of the power rule. If I have the integral of x cubed dx, what this rule is telling me to do is to add 1 to the exponent and then divide by the new exponent, which is really the same thing as 1/4 x to the 4th plus c. And again, if I take the derivative of this, I would end up getting x cubed back. Now note, there is a restriction on when we can use this rule. For example, it says if your exponent is -1, so if we were asked to find the integral of -1, or x to the -1, if I add 1 to the exponent, I would get 0, then I'd be forced to divide by 0, which I can't do. So we might as well talk about this case right now. Anytime you have x to the -1, this is the same thing as the integral of 1 over x dx. And we learned back in chapter 7, what function, when you take the derivative, is 1 over? Well, that one is the logarithmic function. So the integral of 1 over x, or x raised to the -1, is ln absolute x plus a constant. And that would be that rule right there. Similarly, the integral of cos is sine. The integral of sine is negative cos. And I have a little chart that helps, because we start doing integration, people screw up the positive negative. So if we write down s, c, negative s, negative c, s, going down is the derivative. So the derivative of sine is cos, derivative of cos is negative sine, derivative of negative sine is negative cos, the derivative of negative cos is positive sine. Going up this chart is the integral. So the integral of sine is negative cos is negative sine is cos, and the integral of cos is sine. So that chart is quite useful for memorizing our derivatives integration of sine and cos. Another rule for integration says if I have a constant in front of my function, I can bring the constant in front of the integrand, and I can integrate that and then times it by the constant. The integral of an exponential e to the x, so the derivative of e to the x is e to the x, so the integral would also be e to the x. Now when we get to these special cases here, we'll mostly be dealing with ones like this. If we're integrating, say, something that is e to the 3x, well, the integral, if we notice, is going to be itself. Now, if I took the derivative, I would multiply by the derivative of the exponent. And when we integrate, we divide by the derivative of the exponent. And that's what this means right here. Okay, let's take a look at some more examples. So we're asked to find the antiderivative of 6x to the 3/4 plus 12x to the -2/3. And we're integrating this with respect to x. Well, again, neither of these exponents is -1. So I'm just going to be using this basic rule right here, which says I add 1 to the exponent and divide by the new exponent. So if I add 1 to 3/4, and we'll just do this in steps. If I add 1 to 3/4, I'm adding 4/4, which would end up being 7/4. And then I have to divide by 7/4 plus 12x. If I add 1 to -2/3, I end up with 1/3. And I divide by 1/3, and then I have to add a constant. Now, to divide by a fraction, I just reciprocate and multiply. So this is going to become 24 over 7x plus 36x to the 1/3 plus a constant, and that would be my final answer. Whoops, I lost my exponent here. This should be to the 7/4. Okay, now, to check if we're right, if we take the derivative of this, the 7/4 comes out front, I'd be left with x to the 3/4. And if I took the derivative of this, I would get 12x to the -2/3, and the derivative of a constant is 0, so I would get what I started with. All right, this one here, pretty straightforward, just one term. Again, if I integrate this, I add 1 to the exponent, so if I add 1 to -5/6, I'm adding 6 over 6, so that's going to give me 1/6, divided by 1/6 plus a constant, multiplied by the reciprocal, I get 6x to the 1/6 plus a constant. All right, when you get radicals and we're asked to integrate radicals, we have to approach it the same way we did with derivatives. So the first thing I need to do is I need to rewrite it without the radical sign. And now I would just add 1 to the exponent, which means I'm adding 5/5. So 4/5 plus 5/5 is 9/5. Divided by 9/5 is like multiplying by the reciprocal, and that would be your final answer. So as you get better with these, instead of dividing by a fraction and then multiplying in the next step, you can flip and multiply right away. All right, let's take a look at the next one. So now we're asked to integrate cos x minus e to the x dx. So now we want to figure out what function when I take the derivative gives me cos x, and what function when I take the derivative I end up getting e to the x. So for this one, the integral of cos is sine x. Why? Because the derivative of sine is cos. And the integral of e to the x is simply e to the x. And then I add my constant. So that would be my integral for cos x minus e to the x. Now let's take a look at this one here, and if you notice there's a bit of a difference here. I have a u inside this cos function, and I have a 2u inside of the second term. Now remember when we did derivatives, if I had cos of u, and that was my function, and I wanted to take the derivative, I would take the derivative of the trig part, and then times it by the derivative of u, which in this case would be 1. But if we had this, remember, you would take the derivative of cos, which would be negative sine 2u, and then you'd have to times by the derivative of that, which would be 2. And that constant would come out front, and you would end up with negative 2 sine 2u. Well, for integration, it's very similar, except instead of multiplying by the derivative of the inside, we have to divide by the derivative of the inside, because integration is the inverse operation of differentiation. So the integral of cos u, and again we're integrating with respect to variable u, would just be sine u, minus the integral of cos 2u. Well, first of all, I take the integral of cos, which would be sine 2u, but then I have to divide by the derivative of 2u, which is 2, plus a constant. So my answer would be sine u, I'm going to bring that 1/2 out front, sine 2u plus a constant, and that would be the final answer. Now let's take the derivative of this and see if I end up with that. The derivative of sine u is cos u, minus the derivative of 1/2 sine 2u would be 1/2. The derivative of sine 2u would be cos 2u times the derivative of 2u, which is 2, and the derivative of a constant is 0. And now 1/2 times 2 are going to cancel, and I do end up with what I started with, so I know I'm correct. All right, let's take a look at the one with exponentials now that I have a power bigger than just x. So similar as before, the integral of 3 to the x is going to be itself, divided by the derivative of 3x, which is 3, minus e to the negative 4x itself, divided by the derivative of the exponent plus a constant. So my final answer would be 1/3 e to the 3x. When I bring that 4 out front, it would be positive 1/4 e to the negative 4x plus a constant, and that would be your final answer. Okay, let's take a look at this one. Now this one has 4 terms. Don't be intimidated by it. We just integrate each term individually. So the first one, the integral of x to the 3rd, add 1 to the exponent, divide by the new exponent, add 1 to the new exponent, divide by the new exponent, add 1 to the exponent, divide by the exponent. Now this one, bells and whistles should be going off, because if you move that x up to the top, you get x to the minus 1, so I can't add and divide because I'll be dividing by 0. This is that special case. This is ln, absolute x, plus a constant. And why do we have to put absolutes here? Because I'm only allowed to take the logarithm of positive numbers. So that would be my final answer. Now, if you had something like this, if you had, say, the integral of x cubed minus 1 over x squared dx, this is not an ln because I can move that power up to the top just like I would if I was taking derivatives. And now I could add 1 to negative 2 to get -1 and divide by -1 when I integrate. So the only time we can't use that add 1 to the exponent and divide is when this exponent down here is a 1. Now, sometimes we need to simplify before we can integrate. So in this particular case, I'm just going to distribute the x to the 4th. And now I want to integrate with respect to x, so I'm going to add 1 to the exponent, divide by the new exponent, add 1 to the exponent, divide, plus a constant. So my final answer in reduced form would be 1/3 x to the 6th minus 3/5 x to the 5th plus a constant. In this particular case, you would have to FOIL out and get x to the 4th plus 6x squared plus 9 dx. Remember, to FOIL out, you have to get that middle term. And now, it would be x to the 5th over 5 plus 6x cubed over 3 plus 9x plus constant. So my final answer, x to the 1/5 x to the 5th plus 2x cubed plus 9x plus a constant. All right, this is the one that causes the most grief. When you have multiple terms in your numerator over one term in the denominator, what you need to do is you need to divide each term in the numerator by the denominator. Now we can use our laws of exponents to simplify. So this becomes 2 over 3x minus 2 over x squared dx. Now this term here looks a little goofy, that first term, but if you think about it, this is really 2/3 times 1 over x minus 2, and if I bring that up to the top, becomes x to the minus 2. Now, when you have a sum and difference of terms, you can really integrate each one individually. So this is 2/3 1 over x dx minus the integral of 2x to the minus 2 dx. And again, I'm showing a lot of steps here, and eventually you can do a lot of this stuff in your head. So now this is a constant, so that 2/3 can come out front. So could that too, if you'd like. And now I'm set to integrate. So 2/3, hoping you realize that the integral of 1 over x is that special case. It's ln absolute x minus 2 times. I add 1 to the exponent, divide by the new exponent, add a constant. So my first term cannot change. The two negatives become a positive. Now you can move that x to the minus 1 down to the bottom if you'd like, but that would be the final simplified answer. So the key to these, when you have multiple terms in the numerator over one denominator, is you have to split it up first. Okay, we said at the beginning of the lesson that sometimes you'll be able to find that constant. So if we take a look at these initial value problems, so this time we said find the function f of x that passes through this point and has this as its derivative. So the first thing I want to do is find the general antiderivative. So I'm going to integrate the 2x plus 2x plus 7 dx, and the integral of 2x is x squared plus 7x plus a constant. Now this is my function. Now I have an initial condition that that point is on the function, so it has to satisfy this equation. So that means I can plug 2 in for x and 3 in for y. And then I can evaluate my constant. So this is going to be 4 plus 14 plus a constant. This is 18, and 3 minus 18 is negative 15. So now don't stop there. Now you have to rewrite this equation with the constant in it. So f of x would equal x squared plus 7x minus 15. So this is the specific equation now to this function that has this derivative that passes through that point. So this is like our initial value or our initial condition that helps us find our constant. All right, so there's your assignment for today's lesson. The oral exercises on page 356. We normally don't do those, but those are some good practice integral questions. And then the written exercises are as follows. Again, the answers are on the web page, so if you have any questions, check them out or feel free to send me an email.